Hello, my name is Oliver and I'm going to do trigonometry review, and this is done by our group: Oliver, Santino, Jeremiah, Alan and Shay. So let's go on with trigonometry. What's trigonometry? It is the branch of mathematics that deals with the relations between the sides and angles of plane or spherical triangles and the calculations based on them. What we have here is a right angle triangle, and hypotenuse is always the longest side. A and B, the small letters A and B, they are the opposite and adjacent. They are both of the lengths is always shorter than the hypotenuse, which is H. So let's move on. Pythagoras theorem. In any right angle triangle, the area of the square whose side is the hypotenuse, which I represented here with C, the side opposite the right angle, which is here. So you look, it's opposite, isn't it? And the square of the hypotenuse is always equal to the sum of the square of a square and b square. Let's look at the equation: a square plus b square equals to c square, as you can see here. So let's move on. Okay, what is trigonometry ratios? Okay, let's look at the example of a triangle here. To find sine of angle A, you have to take the opposite divided by the length of the hypotenuse here. Remember, in order sine is always opposite over hypotenuse, and remember, hypotenuse is always the longer side, so give you something to remember. And look, and whenever you are going to find a sine or cosine or tangent of an angle, you must look at the line that is opposite or adjacent, and you must identify the hypotenuse, the opposite and the adjacent of the reference angle. So let's look. We got sine of angle A. We have angle A here. Sorry. And so length of opposite length, which is O here, and over hypotenuse, which is here. So we have here sine A is equals to O over H. Let's look at cosine. Is length of the adjacent, which is A here, over hypotenuse. So it's cosine A. Tangent is always opposite over adjacent. So opposite is here and adjacent. So let's move on. Okay, examples of trigonometry. This is what we're looking for. We're looking for x, and we have 24 degrees there, and we have adjacent side, which is 10 cm. So we have to use trigo ratios to solve this. So we're going to use tangent. As you can remember, tangent is always opposite over adjacent. As we look back, tangent over angle, the reference angle, length of opposite leg is over length of adjacent leg, which is tangent A. So let's look. So here we have tangent 24 degrees is actually equals to x divided by 10, because this is opposite and this is the adjacent. So we're going to do a bit of linear, so we're going to move things around. So we have x is equals to 10 times tangent 24 degrees. If you type it in your calculator, you should be able to get 4.4522. That is truncation, and I'm going to round it out to 3 sig fig, so 4.45 centimeters. Simple. Okay, in everyday life, we use it. It has been used in different jobs like aircraft, GPS, especially like how to locate, example, your favorite food stall or your favorite shopping area and stuff like that, or you want to locate someone. So this is very important in GPS. Okay, and also we have architects. They also need to use trigonometry. If not, if not, instead of they want to build 5 stories, if they don't use trigonometry, they're going to build like what, 3.5 stories. So yeah, Pythagoras is also applied into everyday life as well, together with trigonometry, so they're like, you know, interconnected, dependent. So my group has been given the job of sales clerk, so we gotta move on. So question 1, a customer comes in and wants help replacing their old computer monitor. The current monitor that they own is 5 inches high and 15 inches wide. So the monitor size is actually measured by the diagonal, which is from one corner to the other. So what size would you recommend they purchase? So does this ring a bell? Pythagoras theorem in a right angle triangle. So we have actually got two sides, but we need to find the diagonal. The diagonal is a hypotenuse, and the hypotenuse is always the longest side. So Pythagoras theorem, let's take a look. Using Pythagoras theorem, remember the equation: a squared plus b squared equals c squared. Alright, so we got 15 inches high, we got 15 inches wide. So I'm going to let 5 inches be a, 15 inches be b. So I'm going to sub in. So c is actually equals to square root of 5 square plus 15 square, because you still have the square root, because even though if you add a square plus b square, that is not the final answer. You have the square root c square to find the correct answer, to find c. So we have square root 5 square plus 15 square, so it's actually square root 250, 250. So you get 15.81 truncation. You round off to 3 significant figure, 15.8 inches. Let's move on. Question 2. A customer wants to buy a corner desk that extends 10 meters on one side and 4 meters on the other. The desk is going into a room where the end of the 10 meter section must fit into a corner that has an angle of 23 degrees because of a door that opens into the area. Will this desk fit into the designated area? Okay, so based on what I see or observe in everyday, corner desk is always a triangular table. So what we have here is we have 4 meters, we have 10 meters. We want to find theta, you know, because we want to know this angle. We want to see whether it fits into the area of 23 degrees. Okay, if it doesn't fit, then you're not going to have a table to do whatever you want on the table. So we're going to have tangent. We're going to use tangent. Remember our trig ratios? Remember tangent? So tangent is opposite over adjacent. So we have opposite of the reference angle. This theta is our reference angle, and this is our opposite. This is our adjacent. So we want to find theta. So we got tangent theta is equals to 4 over 10. Okay, so theta is actually 21.8 degrees. Okay, it's because of tangent inverse times the fraction 4 over 10. I will show it to you here. Okay, is 10. I'm going to insert. No, I'm not going to do that. I'm going to do -1. Look at that. That is tangent inverse. Okay, let's go back to so once we find the answer, sorry, make mistake again, my bad. 4/10, which is bound to equals to 21.8. I'm gonna put a symbol. I'm gonna put the degree sign. Yes, this. So that is my answer right there. So tangent inverse 4 over 10 is equal to 21.8 degrees. So therefore it can fit into the area of 23 degrees. So let's move on. So let's look at question 3. A customer wants to put a tarp up to serve as an awning over his deck. So what's awning? Awning is just, to cover. So to make sure things stay dry. So he wants to cover it to make sure it stays dry. He doesn't want to get it wet. So he attached it at 39 degrees angle to the deck rail. The deck he wants to cover is 10 meters wide. The tarps in your store are square. What is the smallest tarp he can purchase to meet his needs? So let's look. Okay, we have 10 meters deck rail. This is the top, and this is 39 degrees. Alright, simple. So what are we going to use now? Trig ratios, right? So cosine 39 degrees. So I have put the hypotenuse question mark. Okay, so I'm going to find the answer. Okay, so cosine 39 degrees is equals to 10 divided by question mark. You want to know what question mark is, so you're going to do linear. So question mark is actually equals to 10 divided by cosine 39 degrees. So it will give you the answer of 12.867, but I'll show you on the calculator. So 10 divided by cosine 39, this is what you get. So I actually truncated here, so I'll put it as three significant figure. So however, we are looking for the smallest square tarp, because the tarp is actually a square figure, so we cannot just give it in decimals. So what is our answer? We have to round it up to 13 meters. So that is our answer. Let's move on. Question 4. Oh man, I'm tired. A customer wants to put a bookshelf in an alcove. Alcove is like, it's something like a cave. It's like, I can't tell you. I never live in an alcove. So where the roof meets the wall at 54 degrees angle, she wants to put the shelf 3 meters from where the wall and ceiling meet. What is the height of the books she should buy? Let's move on. Okay, so we got, this is where the roof and the wall meet. So this is 54 degrees here. 3 meters from where the wall and the bookshelf is 3 meters from where the intersection of the wall and the roof. So 3 meters here. So what we're going to use? We're going to use tangent. Get it? Get it? To find the vertical height. Because you should know how to solve this. So tangent 54 degrees. I have actually put a question mark as our vertical height to represent our vertical height. So I want to find a question mark. So I do a bit of linear here. I'm going to put 3 times 10 tangent 54 degrees. So you get 4.129. That is truncation here. So 3 significant figure, 4.13 meters. 3 significant figure, man. So that's the end. I'm Oliver, and let me give you some, maybe a little music. You know what? Never mind. Thank you for your time, and I appreciate your attention. Yeah. So thank you. Yeah, it's getting late, and I really want to thank my group members. They're awesome. Santino and Jeremiah helped me a lot, and Alan and Shay has been contributing as well as to editing the video, and they have done some contribution. So thank you guys. And yeah, thank you.